Hey guys, Richard Holdner here. Let's talk about the much maligned 5-liter 305 small block Chevy. It's quickly becoming my favorite other guy's small block, but here's the question. Should you modify it or just step up to a 350? Let's find out. In this video, we're going to take a look at modifications we made both to a 5-liter 305 small block Chevy and the larger 350. Now, we made common upgrades, the kind that most normal guys would do. We did heads, cam, and intake on the 305, and we also did heads, cam, and intake on the larger 350. But here's the question. If you already have a 305, which is a very common motor, should you go to the trouble of upgrading that motor, or should you just step up to the larger 350, then upgrade that motor? Now, we know that the bigger motor obviously is going to always make more power, but if you already have the 305, can you get good gains by upgrading that little 5-liter? Let's find out. To start off our comparison, we're going to take a look at a 5-liter 305 Chevy. This was actually a tune port version, obviously the very famous IROC motor. So it's a 5-liter tune port 305 small block. This was a stock motor. It was one of, maybe one of my favorite 305s we've ever run, only because it came from the guys at the Chevy race shop. This particular motor was so low mileage that I think it probably was brand new. It may have been one that came off here's my story. I think it came off the assembly line, went to the Chevy race shop, and has never been put in a car and had never been run other than the break-in that they did when they make the motor ready to put in a car. So we got this motor, and it sat for years and years and years at West Tech. And I finally decided to run it and ran it and took it apart to modify it, as we'll see the modifications. And I think I shouldn't have done that. I think I should have kept this thing the way that it was, because it probably was maybe the lowest mileage, mileage or usage 305 tune port small block in existence. And now it isn't anymore because we've modified it. But I digress. We ran this motor stock with a set of long tube headers, a Holley HP management system, and we ran it with no air induction system. Obviously, the long tube headers and open exhaust, an optimized tune, an electric water pump, and with no accessories on it. So basically it's kind of an optimized condition, and that's why this thing makes more power than it was rated at. Run in this condition, the stock internal, stock tune port combination, stock throttle body, stock heads, cam, intake, all that stuff, it made 267 horsepower, and as we have come to expect from tune port motors, it made a lot of torque. It made 333 foot-pounds of torque, and you can see even down here near 2,500 RPM, it had over 300 foot-pounds of torque. Tune port motors make torque, they do very well, but what we did was modify this motor and did upgrades. Now, it's important to note that when you see the modifications on this, it made fairly good power, and it's not just tune port motors that make this power. I did similar modifications on another test before, starting with a 305 throttle body injected motor, and we did basically the same thing. We put a set of Trick Flow, the Super 23 heads designed for the small chamber 305 motor. We put a camshaft in it. In that case, we put a dual plane intake and carburetor on it, and it made about the same power. They get about the same gains, kind of regardless of your starting point. So if you're starting with, you could even start with a late model Vortec motor and not have to upgrade the heads. They won't be as good as these Trick Flow heads, but the stock Vortec motor, a 305, is a good starting point. You might have to machine it to put valve springs in it, put a cam in it, put a decent induction system on it like this Stealth Ram that we're going to run, or a dual plane carbureted manifold, and you'll get good gains from the 305. So let's take a look and see what we did as we upgraded this tune port motor. And in keeping with the tune port-esque configuration, what we did was install the Trick Flow Super 23 175 heads designed for that small 305 bore. We put a fairly decent camshaft in it, not anything huge, something that you might put in still in a street application. It is an XFI 268 cam from Comp Cams. The XFI means it's basically a high lift version of their hydraulic roller stuff. It was a 570/565 lift split, a 218/224 degree duration split, and 113 degree lobe separation angle. The 175s had 175cc intake ports. It had 67cc exhaust ports and 56cc combustion chambers with a 194/15 valve package. The 194 valve obviously helps it fit in the smaller bore size on the 305. We had also a Holley Stealth Ram intake manifold, kind of a a high-rise or tunnel ram style intake manifold with a big box on top of it, and then a dual 52 millimeter throttle body attached to the opening, which is more than enough for this power output. So after adding the heads, cam, and intake on the 305, we upgraded the power output of the motor from 267 horsepower up to 367 horsepower. So we basically gained 100 horsepower from this upgrade. As you can see, we pushed peak power out farther. It was making peak power out closer to 6,000 RPM. Now we did lose a little bit of some low speed torque down here in the 3,500 range. So just know that and that's a combination of two things. The one is the camshaft, obviously much wilder camshaft than the factory cam timing, and also the intake manifold. A long runner factory tune port manifold is designed to make lots and lots of really low speed power because it has very long runners. The Stealth Ram, although it's kind of what I call an intermediate manifold, not ultra long and not ultra short, it still is going to shift power production higher in the RPM range. So we made peak torque at 48 or 4,900 RPM, whereas with the tune port manifold, we made peak torque at 36 or 3,700 RPM. So we shifted it by more than 1,000 RPM going with this combination. But as you can see, it's possible to make good power gains with a 305, and we're not limited there with porting the 175 heads, stepping up in cam timing, going even to possibly a different induction system or a ported version of this one. We can certainly push power way past 400 RPM. And I think it's time that I did kind of a dedicated 305 and show some of the 305 guys, the other guys 305, how you can really make some good power with a 305 combination. But now let's take a look and see when we made modifications to a 350. Find out how a 350, the larger 5.7 liter small block response compared to the 5 liter 305, we put together a 350 combination and ran through a series of tests, adding heads, cam, and intake just like we did with the 305. This particular motor was Westech's Gladiator motor, so it was very famous from all of the runs that it made. It had been beaten to death for years and years and years and probably had, I don't know, maybe it had 1,000 dyno pulls on it. I didn't ever go back and count, but we know that it was hundreds and hundreds and hundreds of runs because it was used forever before finally being replaced by the Gladiator 2. It deserved a rest. But this was a small block, and like the 305, it had some modifications. We started out fairly mild. This was a 355. It had a set of flat top pistons in it, which were replaced. It was 30 over, so it actually had a set of forged flat top pistons in it with valve release. It allowed us to run a bunch of different camshafts because we put some fairly wild camshafts in this and tested big cylinder heads and all kinds of stuff. But in this configuration, it was run with a performer intake, a dual plane performer intake, a 650 Demon carburetor, and it had a very small camshaft in it, which was an Extreme Energy 250 hydraulic flat tapping camshaft. That cam offered a 432/440 lift split, a 206 to 12 degree duration split, and 110 degree lobe separation angle. It had hooker long tube headers and MSD distributor on it. And before the 350 guys want to jump up and down and storm the castle, we put a bigger camshaft in it also, and that's coming up. So take it easy, and so you're not thinking we're favoring the 305. This motor was also equipped with a set of Airflow Research 195 heads, so it also had good heads on it. Didn't have the same trick flow heads. Now we wouldn't want to run the 175 heads for the small bore motor on the 350 anyway. So they both had good heads. They both had similar intake manifolds, as you see, because we're going to put the Stealth Ram on this as well, and even put the same camshaft in it. So it's fairly comparable. Run in this manner with that camshaft and a dual plane intake, our 350 produced 381 horsepower and 427 foot-pounds of torque. But here's what happened after we installed the Holley Stealth Ram intake manifold. The power picked up a bit. We pushed power up to 395 horsepower, although peak torque was down compared to the dual plane intake, down to 416 foot-pounds of torque. But since this was such a small camshaft, it's basically like an RV cam or something, and it works good. Obviously, it makes good torque and stuff, but it's not ideal for a performance kind of application. So here's what happened when we put that same XFI 268 camshaft, and this was a hydraulic roller. The other one was a flat tapping camshaft, but this was a late model block designed for a hydraulic roller application. So basically, it would accept both. All we did was change the lifters out and put the cam retaining plate and stuff. But after putting that XFI 268 cam, which was the 575, 565 lift, the 218, 224 at 50 and 113 degree load separation angle, our peak power jumped up quite a bit. It pushed power up to 436 horsepower. And peak torque, although was not changed dramatically, it was still 416 foot-pounds. So what the camshaft did basically is add a lot of power out on the top end, which we like. And it still had adequate torque. I mean, we're talking about over 400 foot-pounds starting at 4,400 or so, and over 375 foot-pounds even down at 3,000 RPM. So the bigger motor obviously made more power than the 305. So we're going from, we're gaining 60 or 70 horsepower, which is quite a bit from the displacement. So again, you guys get to choose. Would you obviously, if you have a choice between a 305 and a 350, the bigger motor is kind of the way to go. But what if you already have the 305? Now that we've discussed the modifications for both the 5-liter 305 and the 350, before we get to our conclusion, I wanted to cover some of the math involved with this. First of all, we obviously have to compare directly the 305 to the 350, and this is our 305. And here's what happened when we ran the same kind of modifications on our 350. And again, not surprising, the 350 makes more power than the 305, and it makes more power everywhere. But let's do some simple math and we can figure out which one is actually doing better. If we take a look at the 305, we made 367 horsepower using 305 cubic inches. That gives us 1.2 horsepower per cubic inch. If we look at the torque, 349 foot-pounds, based on 305 cubic inches, we have 1.14 pound-feet per cubic inch. So it's doing fairly well, kind of in the range that we would expect for a typical modified small block. And on the 350 side, we made 437 horsepower for 355 cubic inches, giving us 1.23 horsepower per cubic inch, a little bit better than the 305, both in the same kind of range there. And on torque, it made 416 foot-pounds with 355 inches, giving us a specific output of 1.17 compared to 1.14 for the 305. So they're both right in the range. The 355 might have benefited a little bit from having that aftermarket piston and having slightly higher compression. But again, that's the gain from having more displacement. You get more compression with the same piston design, obviously. So you guys can argue back and forth. But what it shows is both of these small blocks were kind of doing what they're supposed to, given the modifications that they made for each one. Now we can get to our conclusion. Okay, guys, what did we learn from our testing run on the 5-liter 305, the other guy's small block Chevy, and the larger 350? First of all, a couple things, no big surprise here. A bigger motor always makes more power. But a lot of guys will point to the fact that, yeah, that's because it has the big bore and head flow and improvement and all that. And honestly, I don't think that that's the reason here. First of all, let's talk about the 305. You can make a lot of power by modifying your 305, which I think is cool, because the 305 really isn't limited by bore size so much as it is limited by the availability of cylinder heads for that bore size. Lucky for us, and lucky for 5-liter owners, the 305 guys, TrickFlow makes that 175 Super 23 head that works on that small bore. So you actually have enough head flow to support quite a bit of power. Now, we've seen 305 combinations make over 500 horsepower. So you can certainly make power if you apply yourself. If we were to port these 175 heads and improve the flow rate, even given that bore size, we could make a ton more power. We could also make even more power if it was a 350, but I don't think that that's because of the bore size. The bore size allows us to have a lot of other cylinder head choices, which allows us to make more power. And the simple fact that a 350 is a bigger motor. So if we put a bigger motor and put the same combination of parts on the bigger motor, you'll make more power. But if we put that same combination on a 400-inch motor, we'd make even more power. So yes, bigger is better, but here's what I like about the 305. If you go out and you go race and you beat someone and you tell them, oh yeah, it's a small block Chevy, a 350 with yada, 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 all of that on it, that's cool. If you say that you beat this guy with a 305, it's even better. And that's why I like the other guy's 305. Armature holder guys, make sure to like, share, subscribe, ring the bell, do all that stuff. More other guys' stuff coming up.